we'll take a look at a new code editor called Deuce that augments normal text editing with direct manipulation features for performing structured program transformations. The new Deuce code editor, on the left, is implemented within the Sketch and Sketch interactive programming system for creating scalable vector graphics. In this example, our goal is to build a program that generates the Sketch and Sketch logo, which consists of 3 triangles that reveal a lambda symbol in the negative space. We will organize the program so that it can be reused to easily generate configurations of the logo with different design parameters. To start the development process, we use normal text editing to define a couple of shapes by calling the library functions rect and line, specifying their colors and positions as arguments. We add the shapes to the list of shapes to draw at the end of the program and then run our code. We started by hand coding the position of each shape with constant numbers. Now we would like to introduce variables so that these parameters can be shared across definitions. Whenever we hold down the Shift key, Deuce displays clickable boxes around the sub-expressions in the program. When we select the 2 zero constants for the top left x positions of the shapes, Deuce displays a menu of transformations to invoke. Hovering over the Make Equal tool shows 2 options for new variable names to introduce. When hovering over each, Deuce previews the transformation by showing the resulting code in the code box. We like the name x1 better, so we choose it. Notice how the new variable x1 has been defined to 0 in the scope above the 2 shape definitions, and the variable is used in the 2 places we had selected. We would like to equalize the remaining parts of the top left and bottom right corners, so we use the Make Equal tool 3 more times. Each of the 4 variable definitions is short. We want to rearrange the definitions so that they fit on a single line. By selecting the 3 variables to move, and the target position after the x1 variable, Deuce provides a Move Definitions tool that moves the selected definitions into a single definition. Here, in our little programming language, we use a 4-element list to simulate a tuple. Next, we use normal copy-paste text editing to define a second line. Our goal is to have the 2 lines form a lambda symbol. As an intermediate goal, let's have the lines make the letter X. We use normal text editing to make the required changes. Now we use the Make Equal tool to equalize the color and width of the lines. In these cases, the Make Equal tool did not ask us to choose which new variable name to use because it came up with only one good suggestion each time. However, we're not happy with the name W1 for the stroke width, so we use the Rename tool to change it. We use the Move Definitions tool again to rearrange the design parameters so they are organized into related definitions near the top of the code. The color of the rectangle is the last design parameter without a name, so we use the Introduce Variable tool to give it a name. At this point, we have defined variables for several design parameters, but the bottom right corners of our shapes do not yet use them correctly. We text edit the bottom right corner of the first line so that it is offset from the initial point, x1, y1. We need to use these expressions for the second line as well. We use the Make Equal tool to copy the new expressions to the second line definition. The X is now snapped together. To achieve the lambda symbol, we need to do some simple math. We use normal text editing to make these changes. Our program now encodes all of the intended relationships in the lambda logo. Lastly, we want to refactor our program so that it can be reused to generate different configurations of the logo. So, we need a single function that produces the logo. We start by introducing a variable for the list of shapes in the logo. We then select the three shapes, as well as the design parameters they depend upon, and move them inside the new definition. The abstract tool turns this definition into a function. Deuce uses heuristics for deciding which expressions become parameters to the function. In this case, we abstract over constants that are explicitly given names. The shapes are now generated by a function parameterized over the design variables, and our logo is defined by a single call to this function. We can generate different variations of the logo by calling the function with different arguments. To create these variations, we first copy-paste the function call twice. Then, we utilize Sketch and Sketch's pre-existing live synchronization to directly move and resize the copies of our design. To finish our variations, we would like to change their colors. We previously encoded the colors as strings. To access a wider range of colors, we employ a domain-specific Deuce tool to convert the color strings into hue numbers. Finally, we use live synchronization to change our design's fill color and the color of the lambda symbol. The structured editing features in Deuce aim to augment the development workflow by automating transformations that can be difficult, tedious, and error-prone with manual text edits alone.